Hello everyone. Are you all geared up for today's lesson? You better be, because today we are taking our time machine to the past. Let's hop on and prepare for a wild ride. So, on this journey, tell me, how far back can you trace your family lineage? You can probably tell us about your parents, grandparents, great-grandparents, or maybe even great-great-grandparents. But at some point, you will stop and probably think, who came before them? Now, what you just did here was an attempt to find your ancestral history. But what if I ask you now the ancestral history of the entire human race? How did they evolve? Whom did they evolve from first? Or who was the first living organism to step onto this earth? That would be way more difficult. Since the origin of the first life on our planet, we know that many different living organisms have evolved and dominated this planet. For example, there was a time when the dinosaurs were very dominant, and now they are extinct. But how can we be so sure about this? We were not there at that time, nor witnessed any dinosaurs. How could we even say that dinosaurs existed? Thanks to the branch of Paleontology, this mystery can be solved now. So, what do you think paleontologists do? Well, they discover the remains of dead organisms like their bones, skeletons, etc., which we refer to as fossils. But how do they figure this out? Well, all these secrets are buried deep in the ground, quite literally. Curious to know how? So, like how we age with time, our Earth ages as well with every geological era. As it happens, nature spreads a new layer of sediment over the older ones. This means the older organisms get buried deeper into the layers of the Earth's sediments, while the new layers remain on top. In other words, the older and deeper the layer is, the older the organism would be, provided that the sequence of the layers is not disturbed. This is one of the ways of finding the time period of an organism. That's fascinating! Now, another way of finding the time period of a fossil is by looking at the rocks. Remember, we have rocks in the sediments? These rocks have radioactive isotopes on them. A comparative study of rocks can tell us their age or their time period. It can even tell us which sediment layer is older. So, those sediment layers whose rocks have less radioactive isotopes will be older. If they have more radioactive isotopes, it means it's a younger sediment layer. Now, if you compare these layers, it gives a relative age of fossils. What I mean here is that all the fossils found in a particular layer indicate that they have lived during a common geological time period. Interesting! It's almost like a forensic report of a dead person that can not only tell the time of death, but the age as well. Here, look at this geological chart. This will give you an idea of how plants and animals have been distributed in different geological periods based on their fossil study. Now, can you guess how many species have been discovered by biologists so far? Want to know about this exciting part? Well, let's find this out shortly after a break.